Hello guys, welcome back. Myself Assistant Professor Gaurang Prajapati from Mahatma Gandhi Institute of Technical Education and Research Center, Navsari. In this video, we will cover the fifth part of the chapter, that is connections of the subject design of steel structure, 8th sem civil engineering. So, just a minute. We have already covered the three different cases in the previous videos. Now in this video we will cover the fourth case, that is of welded connection. In all about three cases, in first case we did the beam to beam web plate connection, second case beam to column web plate connection, in the third case beam to column sheet angle connection. Now in this one we are going to cover the connection of plates using the welded connection. Okay, just a minute. Okay, so let's start it with the data. Example number 4. Design a connection to join two plates 200 cross 10 mm of grade Fe410 to mobilize full plate tensile strength using the soft fillet welds if a lap joint is used, and second, double cover butt joint is used. It has been asked in May 2018 in the 7 marks. So first of all, given data, two plates are there 200 cross 10 mm. Okay, like this, two plates are there 200 cross 10 mm. Okay. If we show, say, let me draw the plan. 200, that is its width, and its thickness, that is of thickness is 10 mm, like that. So we need to connect two plates, one with the lap joint is like this. Okay, and butt joint means both plates are at the same level, and we need to provide, say, on either on one side cover plate, or we can say two side cover plate. Okay, like that. So first of all, two plates are there 200 by 10 and 100% efficiency, that means full plate tensile strength. Okay, that is 100% efficiency. Now first of all, say load is not there in the data. So whenever in the case of the welded connection load is not there in the data, we need to use the tensile capacities formula, that is TDG. Okay, so for that one, so let's start the sum. First of all, using the first case, we can say lap joint. So first of all, for lap joint, if load is not there in the data, we need to use the formula, close number 6.2, page number 32. Let me show you the formula first of all. See, close number 6.2, page number 32. Design strength due to yielding of cross section, formula stands for TDG equals to AGFI by gamma m0. So let's get back to the sum. See, instead of TDG we will use the term P equals to AGFI by gamma m0 as per this clause. Okay, unknown parameters. AG means area, gross area of the plate. Now plate's dimensions are there 200 cross 10 mm, so we cross T 200 cross 10, we will get answer area, that is 2000. Fy, that is yield strength of steel, that is always taken as 250 Newton per mm square, and unknown gamma m0, that is partial safety factor. As per the table number 5, we will get gamma safety factor, that is 1.10. Let me show you gamma 10, just a minute. Gamma m0, sorry, not gamma 10, page number 30, table number 5. Over here we can see gamma m0, first one, resistance governed by the yielding, that is 1.10. Okay, now let's get back to the sum. See, so we were discussing the unknown. First of all, AG, that was area of plate 2000 mm square, Fy, yield strength of steel, that is 250, and gamma m0, that is partial safety factor 1.10. So put down all these three values over here. AG is 2000, Fy is 250, divided by gamma m0, that is 1.10. By simplifying this term, we will get the answer 454.54 into 10 raised to 3 Newton. So let's convert it into the kilonewton, that is 454.54, or we can say 55 kilonewton. So load is there finally. If load is given there in the data, do not need to do this step. Okay, but now right now for this sum is not in the data, load is not given, so we have calculated the load for this one. Now the next term in the welded connection, always decide the size of weld. Now as we know, the theoretical criteria for the welded says the size of weld should be in the range of 3 mm to 6 mm. Okay, so first of all, minimum thickness of the weld, that is 3 mm, and maximum size of weld. So for that one we have two plates that both are of, we can say, 200 cross 10 mm. So thickness of both plates are 10 mm. So minimum thickness will be obviously 10 mm. Now this 10 mm is as per the theoretical criteria of weld greater than 6 mm. So what we need to do, we need to deduct 1.5 mm from this minimum thickness. So 10 minus 1.5, so answer comes 8.5. So we got two range, minimum thickness 3 mm and greater thickness is, we can say, 8.5 mm. But we know that theoretical criteria of the welded connection says that always decide the size of weld between this range, 3 to 6 mm range. So I have assumed the size of weld that is as 6 mm. Okay, you can assume 5 mm as well as, or you can assume 4 mm also, that is completely up to you. Okay, normally don't assume the minimum thickness, you can take 5 or we can say 4, I have taken 6 like that. Okay, so once we got the thickness of, we can say, size of weld, now we need to calculate next one, that is effective throat thickness. The formula for effective throat thickness stands for 0.7 times s, where s equals to size of weld, that is 6 mm, we have already calculated. So ultimately we will get the answer 0.7 into 6, that is 4.2 mm. Okay, that is step number 2 and step number 3. Now moving forward, next step, that is effective length of the weld. Effective length of weld, sent page number 7980, we got this formula, P equals to LW TT FWD. Just a minute, let me show you the formula. Okay, we can see over here. Just a minute. Yeah. See, formula stands for F or Q equals to P divided by LW into TT. So V equals to P equals to LW TT or FA. FA, that is term has been introduced by or replaced by, we can say, FWD. So ultimately this will be the formula. So now finally applying the main formula, P equals to LW into TT into FWD. Now in this, from this formula we will get the length of the weld required. So for this one, unknown, first of all LW, that is length of weld required, this one. Then P stands for load, which we have calculated, that is 454.55 into 10 raised to 3 Newton. TT, that is throat thickness, we have already calculated, that is 4.2 mm. And FWD, for FWD we know that in the design of structure subject, or we can say elementary structural design, we got the two values. One, FWD, that is equals to 158 for, we can say, field welding, and second 159 for soft welding. Okay, usually in the design criteria, these criteria are not given in the data, say either field weld or soft weld. So always go for the, sorry, this one is 189, huh? Not 115. Just a minute, let me write with another pen. This one is 189. Okay, so usually in the design criteria, field weld and soft weld is not filtered, so usually always go with the maximum, that is soft weld. So I am assuming that it has a 189. Okay, so FWD equals to 189 Newton per mm square for the soft welding. So now putting down all the values, first of all P 454.55 into 10 raised to 3 Newton equals to LW unknown, TT, that is, we can say, 4.2, and FWD, that is 189. We have all this value, so simplifying this term we will get value of LW. LW comes 572.61 mm. So round figure value I am taking as a 580 mm. This means what? Say we need to provide total length of weld, how much? That is, we can say, 580 mm. So now let's start the welding. Now we are doing the, just a minute, let me explain with respect to sketch. See, we got the length 580 mm. So what we need to do, we are providing as a lap joint. So lap joint, one plate is like this, other plate is like this. Okay, so where we need to provide the welding. So first of all we need to provide welding, obviously either one at top or we can say at the bottom. Don't need to provide the welding at top and bottom both if you have sufficient length. See, we can see over here sufficient length will be there. How will we decide this length? So for that one, let's understand with respect to plan. See, if we draw the plan of this one, just a minute. See, now this one is my first plate, just a minute. See, I'm showing it in the sketch. This one is my upper plate, while this one is my second plate, the bottom one. So now one thing is for sure, that first of all let me decide one thing. I will provide one welding over here of this length. This will indicate the width of plate, that is how much, we can say 200. So one thing is sure, that out of 580 mm I will use this 200 mm as a welding. Okay, so the remaining term will be 580 minus 200, so it will remaining will be 380 mm, and this 380 mm will be covered in equal proportion this way and this way. So 380 divided by 2, so it will give me 190 mm. So I will provide 190 mm weld over here and 190 mm over here, and I am providing one weld over here. So first weld I will use 200 mm as a width of plate, then the remaining one will be distributed along the both sides, this one. So I will use this kind of welding. Okay, see, over here I have shown over welding over, but don't need to provide over here, just because I am getting the enough length over here, 190. So one upper welding will be enough, that I don't need to provide this one like that. Okay, so let's see step number 4, welding provided on the side weld as well as end weld. So total length of the weld requirement was 580 mm. So first of all, length of end weld, that is width of plate, 200 mm. So out of 580, first of all we need to provide 200 mm. So length of weld available for the side weld equals to total length of weld required minus length of end weld, that is 580 minus 200. So ultimately the remaining one is 380. Now I will need to distribute 380 among the two sides, this way and this way. So simple, we can say 380 divided by 2, that is 190. Okay, so length of weld on each side of the side weld equals to total length of weld available for the side weld divided by 2. So 380 divided by 2, so I will get the answer, that is 190 mm. Okay, so I have shown it over here, 190 like this. Okay, and lastly just cross check the length. Total length of the weld equals to length of the end weld plus 2 times length weld of the side weld. End weld was 200 and side weld is 2 times 190, so I got the answer 580. That was requirement and I have provided it. And finally draw the sketch over here. See, 190 side weld, and this one is 200. Okay, like that. This one is the top, while 190, that is indication of these two terms are there in the data. Okay, so this was the first case in which we connect two plates using the lap joint. Okay, now let's start with the another case, that is in the data they have asked us that we need to connect one using the lap joint, another using double cover butt joint. So let's start it with the double cover butt joint. Just a minute. So talking about first of all double cover butt joint. So in case of the double cover butt joint, let me draw the sketch. Two plates are there at the same level, and just a minute, two plates are there at the same level, and we need to provide cover plates, both one at the top and one at the bottom. I need to connect this one. Okay, we need to provide welding over here like that. So first of all, see, let's first of all calculate the size of the cover plate, as we are going to provide top and bottom two cover plates. Okay, so first of all assume width of the cover plate, that will be obviously width of the cover plate will be equal to the width of the plate on which we are going to provide. Let me show you in the sketch, just a minute. See, this one is my cover plate. Okay, so obviously its thickness, say talking about its width will be, obviously I will keep it as a plate of width of the plate, original plate. Okay, this one. So one dimension is clear. See, assume the width of the cover plate, that is 200 mm. Now next, thickness of cover plate, that is taken as 5 by 8 multiplied by T. That is the theoretical criteria for deciding the thickness of cover plate. Now T stands for minimum thickness. Over here we have two plates having the same thickness 10 mm, so 5 by 8 multiplied by T, answer comes 6.25. let me take the round figure value, that is 8 mm. So ultimately I got the size of the cover plate, that is 200 cross 800 mm. Okay, so cover plate's dimension as final. Then size of weld, which we have already calculated in the first case. Over here I will show the calculation again, just because maybe some can be asked in the two different manners. Say either it can be asked separately as a lap joint or separately as a butt joint. So for that one we have done this part. Obviously in the first lap joint we discuss the size of weld, that is 6 mm, and in this one, but one criteria will be different. Okay, let me explain over here, because in this one we are going to connect cover plate and we can say both plates. So both plate thickness is 10 mm. Okay, while cover plate thickness is, we can say 8 mm. So minimum thickness is 8 mm. Okay, let me show you. Minimum size of weld, that is 3 mm. Maximum size of weld, so minimum thickness of the plates, minimum, that is minimum of, we can say 10, and we can say 8 mm. 10 is 2 cover plate, no sorry, 2 original plates, that is of the dimension 200 cross 10 mm. That is minimum of this, and this 8 stands for thickness of cover plate, which we have discovered in the previous one. Okay, so minimum thickness is 8 mm, but as per the rule of the welded connection, as this minimum thickness is greater than 6 mm, so what we need to do, we need to deduct the 1.5 mm from this one. So we will get the answer 8 minus 1.5, so 6.5. So finally we need to decide the minimum 3, maximum 6.5. So always decide between the range to 3 to 6 mm, and as in the previous case I have taken the 6 mm, so I will take over here also 6 mm. Okay, so as 6 mm. Talking about throat thickness, that is 0.7 times S, 0.7 times 6, so I will got 4.2 mm. Okay, now effective length of weld, that also we have calculated in the previous sum, means in this sum in the above step. So strength of weld, P equals to LW into TT into FWD. P, that is 454.55 into 10 raised to 3, LW unknown, TT 4.2, and FWD, that is always taken 189 maximum value. So we got the LW 572.61 mm, so that is 580 mm, that is round figure value which we have taken, which we have took earlier also. Okay, so now the difference will be, see, almost first 4 steps are almost equal compared to the previous one. Now the step number 5 will be different. Now in this one what we'll need to do, that what, just a minute, see, let me explain you with the sketch, just a minute. Now in this one we need to provide these cover plates, one above the 2 plates and one below the 2 plates. We need to provide the calculation of first only. Okay, we will do the same thing for the second one, so don't need to consider second one right now. So right now I'm considering this first one. Now this one is the cross section. Now if we are consider about the plan is there over here. So first of all what we need to do, we need to provide the welded over here, welding over here, so that means this side, then welding over here also as well, that is means this side. Now this one is the width of the cover plate, that is 200 mm, so 200 plus this 200, so ultimately I will use 200 plus 200, that means I will use 400 mm directly over here as well as over here, total 400 mm. Okay, now I am having the length 580 mm total, from which I have used 400 mm, so the remaining one is, we can say 180 mm. Now this 180 mm will need to distribute in a equal manner at over here and over here. So 180 divided by 2, it will give me answer, that is 90, and that is this one and that is this one. So hope so guys you are getting the concept which I am trying to explain. Okay, first what I did, that is this one is fixed, that I will use the width of the cover plate both side 200 as well as this 200, so ultimately I have total use 400. Now out of 580, if I deduct 400, then remaining one is 180. Now this 180 need to distribute in an equal manner at top and at bottom in the plan. Okay, so 180 divided by 2 will be over here and divided by 2 will be over here, that will be 99. Clear? And I will need to do the same arrangement for the bottom as well as, but we need to show the calculation for only one. Okay, So just a minute. Step number 5, welding provided on the side weld and end weld. So total length of the weld is 580 mm. So first of all, length of end weld, that is 2 times width of plate, that is 2 times 200, that is 400 mm. Clear? So the length of weld available for the side weld equals to, out of total weld 580 minus 400, so remaining one is 180. Now we need to distribute this into equal manner, so divide by 2. So length of weld on each side of weld equals to total length of weld available for the side weld divided by 2. So 180 divided by 2, so I will get 90 mm. So let me cross check the length, that is total length of weld provided equals to length of end weld, that is this one, okay, plus 2 times length of weld on each side, that is this one, 2 times. So see, 400 plus 2 times 90, that is 580 mm. So requirement was also 580 mm. Okay, and finally you need to do this sketch. Okay, in the sketch you will need to show the cross section, that is this one, as well as plan also. These are our dimensions of the welding. Clear? So this is the final sketch of the answer. So this was the chapter number 1, that is connections for you. Okay, I have covered the 4 video for the analysis. In the first video, just a minute, say in the first video, beam to beam connection. Okay, second video, beam to column connection but web cleat connection. In the third video, beam to again column connection but sheet angle connection. And fourth video, plate to plate connection but welded. Okay, so I have covered these chapters examples in 4 different videos. Okay, and in the very first video I have covered the theoretical portion of the chapter. Okay, so hope so guys, the criteria which has been asked in the exams means these theories as well as this all examples have covered in the 5 total videos of this chapter. Okay guys, thank you.